Saxon Algebra 1, Lesson 65. Greetings, students. We're at the beginning of another math week. Of course, if you're watching me on YouTube, you can do these lessons as fast or as slow as you want. I do recommend 4 lessons a week. Watch the video, do the homework. For most students, doing just the odds, do all the practice, but just the odds, that is a really great way to go. 4 lessons a week gives you an easy 4 hours of homework a week, and that is a solid chunk of math. Sometimes I do 5 lessons a week, but honestly, that allows very little breathing room, and it's easy to fall behind if something else goes wrong in your life. Well, not something else, because math isn't going wrong, but you know what I'm saying? There's not much wiggle room if you're doing 5 lessons a week. So I'm fine with 4. Figure you're gonna spend a half hour watching the video and close to an hour doing the math. That is a lot of math. And if you're getting that done, you are killing it. Okay, so, oh look, I forgot to cross off the last 2 lessons last week. So we're here, all right. It's the beginning of week 18. 18 weeks we've been studying since summer. And today we're gonna talk about adding radicals. Now, as I often like to do, let's go back to something we already know and understand to get our bearings. When we multiply variables, we can just multiply them, right? We just shove them together. That is the same when we multiply radicals. We talked about this last week. We talked about this as the 3 little pigs story, because the pigs can live in separate houses, or, you know, they can run together and hang out in houses as well. However, that's multiplication, right? So these look a lot the same. If we're adding, there's nothing we can do to put those 2 together, can we? X and Y are not the same. So there's no way to simplify, right? That's just the same thing. Guess what? Same is true with radicals. If they don't match, there's nothing we can do about it. They stay exactly the same. However, if the radicals do match and we're adding them, then we can put them together. We have 2 of them, so we say 2x. And the same is here as well. If we're adding 2 radicals that match, we can add them together just as if they were variables. So this is what we already know about plain variables. This is what we're learning about radicals. This is what we learned last time, and this is the focus of our lesson today. If you're adding or subtracting, because they're the same difference, right? Subtracting is just adding a negative number. If you're adding, if they don't match, there's nothing you can do. If they do match, you just add them. All right, let's try a few examples. 65.1, ready? I'll give you a second to copy. So we look at this problem, we see pig houses, so we immediately think, okay, in order to add, and we see addition and subtraction, we think, okay, in order to add or subtract, the pigs have to match. We can only add them or subtract them if they have matching pigs. Square root of 2, square root of 2, square root of 2. Fabulous. Now, just as we do here, we can ignore the square root of 2 and just look at the coefficients, look at the numbers in front of them. 4 minus 5 is negative 1, plus 12 equals 11 square root of 2. All right? Clearly, this kind of example, the pigs matched, we just add them. Okay. Let's do another. All right. Again, we see pig houses, we see addition and subtraction. We know it's this set of rules. So now we look at the pigs, a 3, a 5, and a 3. Okay, there's no way to turn that 5 into a 3. There's no way to turn that 3 into a 5. Spoilers, I'll get to that later. We can't change any of these, right? Because these are prime numbers. They're reduced as far as they can be reduced. So all we can do is combine the ones that do match and then just write down the separate ones separately. So here's a square root of 3. Here's a square root of 3. 4 minus 6 gives us minus 2 square root of 3. And then this guy's all by himself. So all we can do is say plus 3 square root of 5. And that is our final answer. Okay? I didn't smiley face him. Whew. Okay. We have 4 of these total. We're halfway done. But then we have another section to the lesson, so don't run away. 65.3. We see addition and subtraction. We see pig houses. We look for matching pigs. There's a 2. There's a 2. There's a 3. There's a 3. Notice that at this point, I'm only looking at the pigs. I'm not looking at the numbers on the outside, which we will come to call the wolves, right? Because the wolves stay out of the house, at least that's the goal, right? In the story is to keep the wolf out of the house. So this is really just like when we learn to add variables, where we just underlined the like terms. Same difference. We're just underlining the like radicals, which make like terms. And then we combine them. So once we notice that they match, we can ignore the pigs and just look at the wolves. That would be minus 5 square root of 2. And then these two together would be plus 13 square root of 3. And one more. Okay, adding and subtracting, pig houses. Let's look at the pigs and see what matches. A 3, a 2, and a 5. None of those match. I'm getting ahead of myself, but I'm going to tell you that in later lessons, we will be looking at pigs where we can reduce them. And sometimes we can make the radicals match. But in this case, there's no way to simplify 3 or 2 or 5. That's just all there is. Nothing matches, so guess what? That's the answer. There's nothing we can do to simplify that. Cute, right? Okay, so that is the step about learning how to add radicals for today. Our second topic is completely different. It's an algebra topic, and it's kind of statistics related. It's called weighted average. And the best example of a real life situation where we often use weighted averages is in classes, especially in college classes. You may be experiencing it in high school, but in classes where different components of the class, the homework, the tests, maybe some papers, maybe an oral presentation, they're not all worth the same weight in calculating your grade. So what some teachers do is they weight some things as more important, weight, W-E-I-G-H-T, that kind of weight. They give you more points for certain types of work in the class and less points for other, so that maybe you take 2 tests that both have 10 items, but one is worth 3 times as much as the other one, right? It's all a question of what teachers think is valuable. So this is a calculation to find the overall total or the weighted average of all of those things. So we're gonna say that there's a guy named Jim, and he took a class, and there were 4 tests in the class. And his scores on the tests were 60, 70, 80, and 90. Well, he improved over time, didn't he? Those are his 4 scores of the 4 different tests. But the tests are not all equal. The teacher, for whatever reason, decided to weight them differently. These are the teacher's weights that they put on the test. So this test is least important in this teacher's view. This one's twice as important as the first one. This one's twice as important as the second one. And this one is half again as important as that one. Do you see what I'm saying? They just increased the value of the test. So obviously, this test matters the most to the teacher, and this test matters the least to the teacher. So what we do is we find what's called a weighted score, and we just multiply. 60 times 1, that means this one's worth 60. This one is weighted 2, so it's worth 140. I'm just multiplying, no magic here. This one is worth 320, and this one, whoops, is worth 540. I'm putting the little multiply signs and equal signs in there just so that you're super clear how I got it. Okay, so I would say this for Jim. He certainly managed to pull himself together and improve as the weights of the test became higher. So at least he, failed a good test to fail. Now, in order to find his average weighted score, we take the total of his scores. So I'm adding these together. There's 10, 16. I'm going to count from the bottom up because it's bigger to smaller. 5, 8, 9, 10. 10, 60. And we add up not the number of items, but the weight, the total weight. Okay? Because that is going to give us the average score. We multiplied these, now we're dividing them down. So now we take 1,060 and divide it by 13, and that will give us, I'm going to just tell you the answer, 81.54 is his average weighted score. This was the total of the weighted scores. And this number is the total of the weights. Okay? Total weighted score, total of the weights, and then that calculates to give us the average weighted score. We don't use these numbers in the calculation because these numbers are in those numbers. So this is our final answer, which is really good news for Jim because even though he had some pretty rough goes on these tests, his average score, his average weighted score for the semester or whatever this is, looks pretty good, right? It looks pretty good. It's there in the range of what most teachers would call a B, 80%. That looks really good to me. And so yay for Jim, right? Because he got his act together on these important tests. Just to point out the difference, the way that I calculate grades for this class, I do not use weights. Every single problem you take, every single problem you work for me, whether it's a review problem or a test problem, is worth 5 points. And it doesn't matter if it's on the final or if it's on a midterm or if it's just a review problem on a March afternoon, every single problem is worth 5 points. So there aren't different weights in my classes. And if you look at that page that I give you, I calculate your average score, but I don't weight anything. So take a look at that when it comes around and think about how different teachers get to make all this stuff up and decide how to grade their classes. All right, now, some teachers would just weight their grades like this, but what a lot of teachers do is say, oh, the first test is worth, I don't know, some random number, 12% of your grade, and the second test is worth 40% of your grade, right? They will do it with percents rather than just these arbitrary weights. So let's look at, for our last problem, let's look at just a second, I didn't write this, example 65.5. We did 4 of the radical problems, and then we're doing 2 weighted average problems. So here comes the last of our weighted average type problems, 65.6. This teacher is trying to accomplish more or less the same thing, but they state their weights as percents rather than just little numbers. So the first information we get in this problem is the weights. So we're going to write these columns in opposite order just because that's how we get the information. All right, this is Susan. Here we put the scores first and then the weights. We're reversing those 2 columns. Don't let that fool you. We're just taking the information as it's given to us in the problem. So the scores will be in the second column and the weights will be written as percents in the first. Okay, so there's the weights, there's the scores. All right, Susan, in the graduate level course Smith R was taking, each of 3 tests was weighted 20% and the final paper was weighted 40%. And in my experience, that's really, really common. 20%, 20%, 20%. Those are the 3 tests that are weighted 20%. And the final paper was weighted 40%. Okay. Now, we just want to check, unless this professor lost their mind, these should add up to 100. 0, 2, 4, 6. Yeah, this equals 100%. Okay, so we just want to check and make sure. Okay, now, how did Smith R do on these? Smith R's scores for the 3 tests were 60%, 70%, and 80%. Another one of these up-and-comers, right? Just like Jim, he's improving. His score on the final paper was 60%. Oh, Smith R, that's terrible. You should have rallied and got the 90% there, right? Okay. So now, what we want to do is, just like before, we want to multiply these together to get our weighted scores. Now, the tricky thing about this is that we have written these as percents, which isn't wrong, it's not bad, but it's just going to make our percents look a little weird. It's just going to make our scores look a little weird. All right, so let's just do them as decimals. So this, again, we're multiplying this, but we're going to multiply 0.2 times 0.6. Here we're going to multiply 0.2 times 0.7. See what I'm doing? We know that percents can be written as decimals. It's 70 over 100, so I'm reducing it, right? I'm reducing this from 0.20 to 0.2. I'm not really reducing it, I'm just dropping off the 0. The score of 60% would be 0.60. I'm just writing 0.6. So let me pick up here. 20% would be 0.2 times 80% equals 0.8. And then 40% would be 0.4 times 60%, 0.6. This, 0.12, 0.14, 0.16, 0.24. Those are the weighted scores. Here are the pieces that I use to multiply. There's the actual weighted score. Right, I just did the little calculation here. And now if we add these up, we'll get his total score. There's 10 and 6 more. 1, 2, 3, 4, 5, 6. Yikes. 0.66, which equals 66%. Because of the way percents work by converting them to decimals, we don't have to do any division in this problem. All right, the percents just calculate out beautifully. So we don't have to worry about that. And see, we've calculated decimals here, and then we just convert that back into a percent, right? Just bump the decimal place twice. So he got 12%, 14%, 16%, 24%, for a total of 66% on his grade. This is the right answer. And it's a sad story for Smith R. Let me just double check. Yeah, that's the right answer there too, okay? So when you're using percents, the calculation is actually a bit simpler because you simply multiply the decimal of the weight times the decimal of the score, and that takes care of all of the math that we need to do. All right, this is more likely what a teacher would actually do in college, is put these kind of weights on it. Okay, guess what? That's the end of lesson 65. You're ready to go to college. Yay! Goodbye.